Very good morning. Welcome to Diksuchi. Today we'll have a look at Indian space program's accomplishments and the way forward. Among few of the most significant and notable contributions, the first and foremost thing is Mars Orbiter Mission 1, which is also called Mangalyaan 1. It was India's first interplanetary space mission, which was launched in 2014, that made India the first ever country in the world to make it successful in its first and maiden attempt itself. And India was the fourth country in the world to orbit the Mars after USA, European Union, and Russia. And the next project was AstroSat 1. It was multi-wavelength space-based astronomy telescope. Its intention was to find X-ray, UV, and optical sources in the universe. It was in service for 7 years since its launch in 2015. And the next successful project was Chandrayaan. We are all celebrating the success of Chandrayaan 3. And it's very interesting to see the results that are being sent by the laser-induced breakdown spectrometer, which is on board Pragyan rover. We can clearly see the presence of certain elements on the surface of Moon, such as chromium, aluminium, titanium, sulfur, oxygen, calcium, etc. And the hunt for hydrogen is still on. And apparently the Pragyan rover will be in action for one more week. So I'm sure we'll have some more fascinating results as well. Now coming to the upcoming missions of Indian Space Research Organization, the first thing is Aditya L1, which is all set to be launched today in the forenoon from Satish Dhawan Space Station, Sriharkota, Andhra Pradesh. And Aditya L1 is India's first space-based solar telescope, which will be placed in an orbit around the Lagrangian point 1, which is one among 5 points of equilibrium in the Sun-Earth system. Being placed at this point, the satellite will have an added advantage of seamlessly looking at the Sun without being affected by the eclipses and the occultation. And also the satellite will need less and minimum fuel to remain in its position as well. And Aditya L1 is carrying 7 scientific payloads to undertake various tests on the Sun. And they are visible emission line coronagraph to study the corona. Apparently, it will capture a couple of thousands of pictures of corona every day. And the next one will be SOOT, which is Solar Ultraviolet Imaging Telescope, which will be capturing images of chromosphere and photosphere. And the next one will be SOLEX, which is Solar Low Energy X-ray Spectrometer. It will be studying the low energy or soft X-rays that are being emitted by the Sun. And the next one will be Helios, which is High Energy L1 Orbiting Spectrometer. It will be studying the high energy or hard X-rays that are being emitted by the Sun. The next one will be Aspects, which is Aditya's solar wind experiment, which will be studying the solar wind of the Sun. And the next one will be PAPA, which is plasma analyzer package for Aditya, which will be studying the plasma ions and the movements and direction around the Sun. The next one will be advanced high resolution triaxial digital magnetometers. This will measure the magnetic field around the Sun in its all 3 axes, BX, BY, BZ. The next project will be NISAR, which is NASA ISRO Synthetic Aperture Radar. It is first of its kind dual frequency synthetic aperture radar, which will be used for remote sensing and imagery and for Earth observation. It will be mapping the Earth 4 to 5 times a month to identify various factors of the globe, such as climate change, deforestation, and polar ice cap mass, biovegetation mass, and natural hazards such as earthquakes and tsunamis, volcanic eruptions, floods, etc. The next and it will be world's most expensive synthetic aperture radar as well. And it will be using L-band and S-band transponders, and the L-band transponders will be made at NASA, and the S-band ones will be made at India, ISRO. And the next project will be Chandrayaan 4, which is also called Lunar Polar Exploration Mission, or LUPEX, which is joint project between ISRO and Japan's Aerospace Exploration Agency, JAXA, which is set to be launched in coming couple of years. And the next project will be XPOSat, which is also called X-ray polarimeter satellite. It is India's first kind of satellite to measure the polarization of cosmic X-rays that are being emitted by different astronomical sources such as pulsars and active galactic nuclei, supernova remnants, and Crab nebulae, etc. And then the next project will be SpadeX, which is also called Space Docking Experiment, which is very interesting experiment, which is basically a twin spacecraft based experiment to find the rendezvous and docking capabilities, which will find their applications in human spaceflight programs and onboard satellite services, etc. in future. The next project will be AstroSat 2, which will be successor of AstroSat 1. Its aim is to find at least 50 brightest astronomical sources of X-rays. The next project will be Mangalyaan 2, which will be successor of Mangalyaan 1, which will undertake deep studies in the atmosphere of the Mars. And the next project will be Shukrayaan, which will be studying the atmosphere of Venus. And the next project will be most important and prestigious one for India, which is Gaganyaan, which is also called Human Spaceflight Program. And this will be conducted in 3 phases: Gaganyaan 1, 2 and 3. Gaganyaan 1 and 2 are uncrewed space missions which will study various capabilities that will ultimately pave way for inaugural crewed space mission, which is Gaganyaan 3 in 2025. And Gaganyaan 3 is going to lift 3 astronauts into the low Earth orbit for 7 days. In this direction, ISRO has done significant improvements in terms of conducting pad abort test and reusable launch vehicle technology demonstration and crew capsule module test, etc. Apart from this, India and ISRO are encouraging indigenous institutions, technocrats and technology groups to come forward and be a part of India's technology building and space program. So thank you so much. Jai Hind.